Hello all, my name is Gürkan TOPKARA. I am a senior student of Electrical and Electronics Engineering at İzmir Katip Çelebi University. In this video, I will present you my project, which is integration of touchscreen to ARM-based electric vehicle charger electronic board and software design of communication library. Let me introduce my supervisors also. Professor Dr. Savaş Şahin from İzmir Katip Çelebi University, Mehmet Uğur Soydemir from İzmir Katip Çelebi University, and Gürkan Şahin from Kent Ege Electronic Research and Development Center. The production and sales of electrical vehicles have increased rapidly in recent years. With this increase, it has become inevitable to develop equipment that will meet the needs of the electric vehicle users. In this study, the design of communication software library of the electrical vehicle charging station and a screen designed to follow the charging process to user has been carried out. In this study, a human-machine interface screen is chosen for displaying measured data. STM32F103C8T6 is used as 32-bit ARM-based microcontroller. The connection between the HMI screen and microcontroller is provided with UART communication protocol. The measured data are arranged and sent to screen for displaying the data. The STM32 CubeID environment was used to develop communication software library in this study. The Divine Graphic Utilized software, which is DGUS, was used to design screen pages. This is the DGUS software interface which we use to design the page of HMI screen. This is the CubeID software which we use to develop software library of communication. So let's continue with software development part. Divine HMI screen has a special communication messages format, which is a string of hexadecimal numbers in order. As an example, page changing messages is shown below. This is an example of string message which we use to change by using microcontroller. These all bytes have unique means here. For example, 5A5 is frame header, as you can see here. 0807 is data length. It's corresponding to hexadecimal value, of course. The 82 is write instruction, and it goes on like this. And the last byte is the necessary byte which represents the page ID. I mean, if we write here as 2, then the HMI screen goes to second page. So we determine the page by using the last byte here, as you can see. And then these are the all messages. These are the example messages actually for communication library. So this was the scenario for page changing of the DGUS screen by microcontroller. So how do we know that the message is sent only when it's needed? To control this issue, we have used receiving string messages comes from HMI screen to microprocessor. As you can see on the screen, it's an example for total battery capacity OK button. The picture shows necessary settings for getting receiving messages. We have designed it with special format, of course. We set the VP address as 3000, so we will understand that the OK button is pressed when the receiving messages comes with 3000 VP address. As you can see here also, the total battery capacity OK button is presented here. The K value is the value which comes after the 3000 VP value. We set it here, as you can see, and we just write it here. So with this concept, the all messages that we need is shown here also. This value is setting from here, and if the button is pressed, the data comes from the HMI screen to microcontroller. But to do this, we should enable the data auto uploading here also. So this was the technique for development of software. These are the setup for testing software and hardware part. Left side, we connect serial cable, as you can see, since we use the UART protocol. We connect the serial cable with HMI screen and try to create the communication scenario. On the right side, the electrical charging board is tested with external load. So these are the results after communication is successfully completed. This is the connected page and this is the charging page. So this is the data of current of line 1 on the graph, of course, as you can see. This is the data of current of line 3 and this is the graph value. As you can see, you can reach the value on graph. So as a conclusion, in this study, integration between the electric vehicle charging card and screen was carried out. The communication between screen and microprocessor was carried out via WART protocol. As a result, the need of electrical vehicle users have been met with a user-friendly display. So thank you so much for your attention. I am open to answer any of your questions that may you have.